I'll just point out, she has, if you go through the OSU manual, again, this information is going to be provided to you. They're saying choose your basal loading rate, BLR. That's, we've given you 0. In this particular design we did 0.3, okay? That is in the units of gallons per day per square foot. How many gallons do I want to put in 1 square foot of soil? 0.3 gallons. That's what that means. Basal loading rate. All right, go ahead and jump to the next one.
Oh. Ooh, what's already right there?
All right, basal width equals the lineal loading rate by the basal loading rate. 2.4 is what we gave you on the lineal loading rate, and 0.3 was the basal loading rate right up here. Equals 8 feet. Now let me explain what this is. Who cares? The basal area, the basal width, is the area that gets scarified. The total size we've just calculated is 8 feet wide. Total. It is 5.6 feet in addition to the distribution area. So if I drew a cross section of my mound here, here's my distribution area, it's 2.4 feet wide. My scarification area is 8 feet wide. And what we're saying is water is doing this. That's where treatment's going to occur, by and large. So we are going to scarify this area here. Now if you go a little beyond it, who cares? You want to get that sod shaved down to the ground, get in there with a backhoe teeth or a chisel plow, and tear this area up so you get a good interface for your sand. The basal area is really, all that it's dictating is the area that gets scarified, so you know the area that treatment's supposed to occur in your system. Okay. Of course, the basal length is the same as the distribution length. All right, sand fill depth. Determine the sand fill depth. This is fairly simple. You need to know your vertical separation distance by code. Vertical separation distance is 24 inches in this. In most scenarios in this county, if it's not, we tell you. So it might be 3 feet. Vertical separation distance minus what's existing in the soil already. Vertical separation distance is the distance from the soil absorption component, the distribution component, down to the limiting condition. So we simply subtract 24 minus 17. The sand fill depth up here, say here, is then 7 inches. Make sense?
Don't seem like much.
Sand?
Yeah.
That's what it is. If it were shallower, Fred, if it were 11, of course it'd be more.
Just saying.
The minimum, I should point this out too, the minimum our code spells out is 6 inches minimum. So if you're doing a mound and you really only needed, let's say you only needed 3 or 4 inches, you automatically go to 6 because like Fred said, it's not much. If you're just scattering an inch or two of sand on the ground, you're not going to get a good interface there. So we said minimum of 6 inches on the sand fill. All right, so now we're going to do the downslope. This is upslope. And hopefully this is, I'm hoping as we go through, this is a bit intuitive to you. You understand, because you've done this for so long as an excavator, that when ground is not level, that it's not going to be 7 inches on this side, right? It's going to be something deeper. That's level, that's not. So the downslope is simply the 7 inches on the upslope we had times the width, this width here, 2.4, 2.4, no, pardon, plus. Yeah, plus, times the slope. And the slope of this particular project is 5%. So 5% is the same as 0.05. 7 inches plus those multiplied together is 8.4 inches. Therefore, on the top side, on the 5% ground, I'm going to have 7 inches. On the bottom side, I'm going to have almost 8.4 inches of sand. Makes sense. Now we're going to figure out the aggregate depth. This is fairly simple. There's no calculations here, but you just want to at least take note of what they are. Normally, this can be done with 8 to 9 inches of gravel. And this cap can be done with 6 inches of cover. Now, various design guides sometimes recommend 12 inches of cover for frost protection. If you choose to do that, whatever, that's fine. If you want to do that. The design we're going to go through today, because the example already had it, I'm just going to use it the way he did it. He used 12 inches of aggregate. That's fine too. You add a little bit more, the mound just gets taller. So we're going to go through that. So the numbers we're going to use today for our job is going to be 6 inches of cover and 12 inches of aggregate. Okay. Just again, these are all stepwise in this manual. So what we're doing here is just pulling right out of the manual, and we're just going stepwise through it.
It's not as clear as you would, so
Oh.
it's nowhere near as clear as
I
you
hope that was a compliment.
You get carried down here, forget it.
Oh. All right, so the next step, the upslope width. Upslope width equals the mound side slope. Now, I'll explain what all these are. Plus the fill height. That's part of the times, the fill height times. Get a multiplication in there. And a correction factor. So we're going to get the upslope width, that's this right here. The upslope width from here to the toe. From the distribution area to the toe on the upslope side. That's what we're trying to calculate there. Okay? Now, the side slope, we want to construct this mound with a 3-to-1 slope. Okay? If, and I've heard this comment lately, and this is how you can deal with this. I don't think that's enough soil to adequately stop seepage from coming out. The manuals say it is. Most practically experience that we've had, it is. If you don't like it, choose 4-to-1. Choose something else. The higher you make this number, the longer this toe extends. If you want it different, if you don't like the minimum, choose something else. You can go with 4-to-1 or whatever else. It's going to make it a much more gradual of a grade by choosing a different number. So anyway, mound side slope is 3. The fill height is, let's see, we're doing the upslope, is 7. 7 inches here, 12 inches here, because remember we said in our design we're going to use 12, plus the cover. 6. Okay? Side slope, these are inches. 7 inches for the sand fill, 12 inches for the aggregate in our design, this one we're doing, and 6 inches of cover. Now there's a correction factor. Why the correction factor? What this is trying to do is try to make it so that the upslope side has a little bit less toe and the downslope side has more toe. Because why? Because we just said that when water hits that surface, it's going to go downslope, right? Not upslope. So this is, we can be less conservative with this than with this area here. We're doing the upslope side. So 5% slope, Jason, you can read it for us. Let's see, correction factor?
0.87.
0.87. That didn't sound like Jason. All right. There's your correction factor so that this is shrinking up a little bit. So when we do all this, we add all this together, we multiply, we're going to get 65 inches. When we do all that math, or 5.44 feet. Okay. So that's all there is to figuring out the upslope. The downslope is done pretty much the same way. Downslope width. So I'm going to just use the same formula right here, guys. Drop it down here. So we're going to say again, it's 3 is the slope factor, but now I'm doing it here. So instead of 7, it's 8.4. Because now on the downslope side, I have 8.4 inches the same, not 7 like I did on the top, because we already talked about the slope of the ground. So 8.44 inches plus 12 inches of aggregate plus 6 inches of cover. Sorry about that. Times 5% correction factor, 1.18. 1.18, yep. 1.18. Of course, coming back to algebra, always add your addition first. Do that math first, and then multiply your 3 times that, and then times that. Remember that? Order of operations, algebra.
Mm-hmm.
All right, downslope with 93 inches, or 7.8 feet. Multiply all that out. Okay. So let's make note of that up here so we can use it later. 5.4 feet up, down, 7.8. Okay. Any questions? Not too difficult. Step by step. Sorry for the people who don't do this for a living. It's sure boring. All right. End slopes. So now we figured how much. We figured out how much of this and how much of this. Now we've got to figure out how much to build the mound out away from the end of the system. Okay, and it's done again, very similarly. End slope equals the side slope factor, 3, times the average of this. So we know that one side is higher than the other, so we're going to do an average. So that's 7 inches plus 8.44 inches divided by 2, right? Average. 2 numbers divided by 2 gives you your average. And we do not have, plus, that is the average sand depth. This is the height of the aggregate, height of the cap. There is no correction factor because we're not upslope or downslope now, we're at the end.